let me present you a DeSciNet. So DeSciNet is all about causal modeling. The importance with causal models is that you want to identify confounders, where you explicate what variables cause what other variables, and that way disambiguate from A causing B or B causing A or another variable causing both A and B, right? Telling that apart. Once you explicate your causal assumptions, you have tools at your disposal to reason through those models counterfactually. You basically intervene on such a model and then calculate the cause effect chains back to the variables you care about, right? So then essentially an agent takes a causal model, infuses it with observations, and then reasons through its possible actions or inactions and the consequences thereof. So how to get to such a model in the first place is the question. And this is what DeSciNet is about. DeSciNet, like the best thing you can do is to just propose a causal model and then test it, whether it conforms to the data that you have, the observations. And for observations, we use arbitrary constellation metagraphs because they really are the data validation pipelines that sit between physical reality and abstract causal models, right? But then DeSciNet itself is a metagraph where users can upload arbitrary causal models that ingest arbitrary data from other constellation metagraphs and explicate the causal assumptions that usually is found in reality, not in the validation logic, to ingest that data and make predictions about variables that users cares about. And then as future observations come in, we know what the actual outcome was, and the difference in that really is a surprise, right? If a model predicts everything perfectly, we're good. So let's walk through an example of how that works with DeSciNet. To begin with, I have a new empty DeSciNet cluster running on my machine, and there's a script sending demo transactions to this that I'm going to start here. So first thing it does, it generates a private key and DAG address for us, right? Easy. Next, it declares two variables by sending two messages to the metagraph. First thing, it declares a human position long variable, and the second message here declares the human position lat as a variable, right? And both of them declare an authority of the key we just generated. And that means only our key pair had the authority to append new measurements of that variable to the DeSciNet state. This is just preliminary. In future releases, this authority should be the metagraph where the data is sourced from. Next, after the variables are uploaded, it fetches the IDs of these variables, which can be cross-checked with the normal HTTP custom route here, right? These two variables are implemented. And next, we want to reference those variables in a causal model. So let's just upload a causal model here, right? This uploads a causal model with a specification being right here. First of all, specifies the author also of being us. That means if this model becomes a consensus model for a time, all the rewards are directed to this address. Next, it specifies the external variables we just defined previously as an input, right? And secondly, it defines three equations here, right? And essentially what they say is the position of the human is equal to the last measurement plus some random deviation depending on how much time passed since last observation. And this basically models the how humans move through space. And essentially we can now backtest this on Google location data, which I haven't yet implemented, but just imagine, right? And we see that this roughly gets it low surprise, except if we boarded the plane when there's a high surprise, right? Positions changed too far too quickly. So then anybody who incorporates airplanes flying from airport to airport in a model would have a model that is more surprise minimized, thus becoming the consensus model and thus receiving the rewards instead of us. And that really is the power of DeSciNet, where anybody can figure out what is wrong in the current model and can improve it and can earn